So welcome to Electronics Lab, and you are watching Signal System lecture series. And today the topic of discussion is the some elementary discrete time signals. Okay. So in this topic we will see some elementary means standard discrete time signals like unit impulse, unit ramp, unit step signals. Okay. So these are important for describing the signals in terms of the discrete time systems. Okay, so let us see that. So elementary discrete time signals. So in this case, we have number of signals, that is the elementary signals, that is required for analysis of discrete time signal and systems. Okay, so let us see how the signals are there. Okay, so first signal is your unit sample sequence or unit impulse. Okay, so this is uh, a discrete time signals. Okay, so this is the standard discrete time signals. So let us see that. So this denoted as del of n. Okay, so this is denoted as del of n, and it is defined as, so del of n equal to 1, del of n equal to 1 for n equal to 0. Okay, so if n is not equal to 0, the del of n equal to 0. So it is defined for only n value when n value equal to 0. Okay, so when n value equal to 0, the del of n value equal to 1, and it is 0 everywhere. Okay, so in other words, the unit impulse sequence, you can see the unit impulse sequence is 0 everywhere except that at n equal to 0, where this value is unity. Okay, so this signal is sometimes referred to as a unit impulse signal. Okay, so this is your del of n. So you can see this is the diagram of del of n. So in this case, at n equal to 0, the value is unity. Okay, and everywhere you can see these are the values of n. Values of n, that is 1, 2, 3, 4. In this case, the value of del of n equal to 0. Okay. Similarly, it is also in the negative axis also. The value is 0. Okay, you can see this is the value at n equal to -1. The value is means 0. Similarly, n equal to -2, the del of n value is 0. Similarly, so on and so forth. So it is defined for only del equal to n equal to 0. So del of 0 is equal to 1. Okay, and all the values are equal to 0. Okay, so this is our unit sample sequence or unit impulse. Okay, in discrete domain. Okay. So similarly, we have unit step signal. Okay, so unit step signal. So unit step signal is denoted as u of n. Okay, so it is denoted as u of n and defined as u of n equal to 1 for n is greater than equal to 0. Okay, and 0 for n is less than 0. Okay, so let us see how the graphical representation of u of n. So you can see this is the graphical representation of u of n. So when n is greater than equal to 0, the value is equal to 1. Okay, you can see the value is 1 for n is greater than equal to 0. Similarly, for n is less than 0, the value is u of n equal to 0. Okay, so this is defined for u of n. So u of n value is equal to 1 for n is greater than equal to 0, and all the value is 0 for n is less than 0. So n is less than 0. These are the values of n is less than 0. So in this case, this u of n equal to 0. Okay, and u of n equal to 1 for n is greater than equal to 0. Okay, so this is a graphical representation of u of n. Okay, so next standard or elementary discrete time signal is that unit ramp signal. Okay, so there is a unit ramp signal. So it is denoted as u of r of n. So it is denoted as u r of n, or you can see r of n also. It is denoted as r of n also. Okay, so it is equal to n for n is greater than 0, and it is 0 for n is less than 0. Okay, so this is the means u of rn or u r of n. Okay, so its value is n for n is greater than equal to 0 and 0 for n is less than 0. So let us see the graphical representation of u of rn. You can see uh, at n equal to 0, the value is 0, and at n equal to 1. So what is the value? At n equal to 1, the n equal to 1 value equal to, you can see, so it will be 1. Okay, similarly n value is 2. 2 means it will be 2, then 3, 4, then 5. Okay, so likewise, so this is the u r of n, or you can see r of n. Similarly, for negative values of n, the value of this unit ramp signal is your 0. Okay, these are the values of u of Rn for negative values of n. For positive value, it is equal to n. Okay, this is the unit ramp signal. Okay, this is the unit ramp signal. So let us see the exponential signal. Okay, so exponential signal is in the form of x of n, which is equal to a to the power of n. Okay, for all n. So this a can be real values and complex values. Okay, so for the real value, if a is real, the x of n is a real signal. Okay, we can see the means diagram of this x of n. So this is the x of n values for real values of a. So you can see it is the 0 to 1. This value is keeps on decreasing. Similarly, greater than a, this is increasing. Okay. So then we have the between -1 to 0. This is the graphical representation of x of n. Similarly, this is the less than -1. Okay, when a value is less than -1, this is the graphical representation of x of n. Okay. So similarly, this a can be complex values also. Okay, so this can be expressed as r means e to the power j theta, or you can see this r theta. Okay, so in this case, what is r and theta are the parameters. Okay, so we can express the x of n as the x of n equal to this one. Okay, r to the power of n e to the power of j theta n. So e to the j theta equal to cos theta. E to the j theta. It is according to Euler's formula. It is cos theta plus j sin theta. Okay. Okay. So this is the express as x of n. Okay. So it will be j theta. Okay. So now the it is the means parameter value is complex here. Okay. Similarly, we have the unit parabolic signal. Okay. So let us see that. So this is the unit parabolic signal. So we can see in this case uh, the it is denoted as p of n. So p of n equal to n square divided by 2 for n is greater than equal to 0. Similarly, it is 0 for n is less than 0. Okay. So this is the unit parabolic signal. So let us see how the graphical representation of this signal looks like. This is the graphical representation of unit parabolic signal. Okay, so you can see the value for n equal to 0. If we put here n equal to 0, it will be p0, which is equal to how much? P0 equal to 0. Okay, similarly p1. So what is the n value is 1? It will half means it is 0.5. Okay, similarly p2 it will be 2 square, so it is 4 by 2, it will be 2. Similarly, P3 it is 4.5, P4 it is 8. Okay, so this is the called the parabolic signal, unit parabolic signal. Okay, so next one is your unit signal signal. Okay, or sequence you can say. Okay, so it is the denoted as this SGN n. Okay, so it is the 1 for n is greater than 0, and it is 0 for n equal to 0, and -1 for n is less than equal to less than 0. Okay, so this is called the signal. Okay, or signal sequencers. Okay, so this is the graphical representation of a signal sequence. So you can see at this value n equal to 0, the value is equal to 0 till this is 0. Okay, and n greater than equal to 0, the value is 1. Okay, similarly n is less than less than 0, this is value is -1. Only at n equal to 0 it is 0, and if n value is positive, this is 1. If n value is negative, this is -1. Okay, so this is called the signal or signal sequence. Okay, so these are the some elementary signals of discrete time signals. Okay, elementary discrete time signals. Okay, so we have seen that unit impulse from sequence, then unit step sequence, then unit ramp sequence, then we have the unit exponential signal, then we have the unit parabolic sequence of signal, then we have the unit signal sequence. Okay, so these are the some elementary discrete time signals. So these are important for analysis of our discrete time systems. Okay, so that is how it is important to know this type of discrete time signals. Okay. So thank you for watching this video. Okay, so if you have any doubt, please free to ask me in the comment section. Okay, so thank you all. Have a nice day.